Hi everybody, today we gonna present to you the following topic, Outlier Detection. First, what is an outlier? Well, it's an observation that deviates significantly from the rest of the data in a dataset. In other words, an outlier is a data point that is significantly different from the rest of the dataset. In this picture, you can see it is a value that stands far away from the general pattern of the data. Outliers can appear due to errors, variability in the data, or sometimes they represent important real phenomena. So, what is the importance of detecting outlier? Detecting outlier is important because they can strongly affect our analysis. In this slide, we present the following points. First, they can distort predictive models. Second, they influence data analysis and decision making. And finally, they help identify anomalies or meaningful patterns. Now, there are different methods for outlier detection. One of them is interquartile range, also known as IQR. It measures the spread of the middle portion of the data, and it is calculated as the difference between third quartile and first quartile. Q1 represents the 25 percentile and Q3 represents the 75 percentile of the dataset. For this method, exists the following detection criterion. To detect outliers using IQR, we define lower and upper bounds. Any value below the lower bound or above the upper bound is considered an outlier. In this picture, you can see a box plot with their respective outliers.
Well, the second method of outlier detection is the standard deviation. The standard deviation measures how spread out data points are from the mean, and is represented by the next equation. The standard deviation equals to the square root of the summatory between the difference of each data point and the mean to the power of 2, all divided by number of data points. And when a value is considered an outlier, well, a value may be considered an outlier if the difference between this value and the mean is greater than a standard deviation multiplied by k. K is typically 2 or 3. This number is decided by the data analyst. The last method is the z-score. The z-scores indicate how many standard deviation a value is from the mean and is represented by the next equation. Z equals to the difference between the data point or the value minus the mean, all divided by the standard deviation. That gives us the z-score. With the z-score, a value may be considered an outlier if the z-score is greater than 2 or 3, like k in the standard deviation is a value or a number decided by the data analyst.
Now let's see how to apply these methods in Python. First, we need to create a data frame with some example values. Then, for IQR method, First, we calculate Q1 and Q3 using percentiles. And then we calculate the IQR with the difference between Q3 and Q1. After that, we define the lower and the upper bound with their respective equations. For lower bound, we use Q1 minus 1.5 multiplied by IQR. And for upper bound, Q3 plus 1.5 multiplied by IQR. Finally, we filter the data to identify values that fall outside these limits, which are our outliers.
Let's continue with the standard deviation method. First of all, we need the mean of the data frame. Then we need the standard deviation. We don't use the entire equation, we use a method that Pandas already has. Then we define the k number, and in this case we use the value 2. And then we filter the data frame with the detection criteria that we already seen, is the absolute value of the difference between each value and the mean if they are greater than the standard deviation multiplied by k number. That gives us the outlier of this data frame. With this method, the outliers is the number 9 with a value of 100. Well, in this case, for the Z-score method, we need to import a class called stats from a library SciPy. And this library helps us to get each Z-score of the data frame. And then we define a threshold. With this threshold, we filter the data frame to get each outlier. With this method, the outlier is again the number 9 with the value 100.